the other way that we could go from vertex form to factored form, and again, I don't know that many of us would think to do this, or that it's even more efficient than what we had talked about last time, where we took our equation in vertex form, we then converted to standard form, and then factored it. Okay, so we're basically, to get it to factored form, we have to write in all three forms already. But the other thing that we could do is we could solve for the x-intercepts. And then use those points to write the factors. Okay, so use points to write factors. And what I mean by that, let's see, what does this end up being? Let's just do it real. I don't want to do that. I don't want to do that. We're going to save that. We're going to basically do that in the next unit anyways. So let's just simplify that and just leave it at that, that knowing if we want to write in factored form, if we know the x-intercepts, we can kind of reverse that process, right? Where we know that when we factor, we take each factor and set it equal to 0 to get its x-intercept or its solution. So if we reverse that, we start with x equals our x-intercept. We get one side to be 0, and there are factors, okay? So just another way of how you can go from that factored form, or excuse me, vertex form to factored form. But let's just stick with method 1. Again, we'll kind of do this process in our next unit. So the last conversion is, if we start in factored form, can we get that in the other two forms? So first, going from factored form to standard form, just multiply the terms. That's really all that we need to do there. Okay, I would think that one hopefully feels a little more straightforward than some of the others. So we just need to multiply all the factors. Okay, and how you do that, it does not matter to me. Okay, when we have the equation 2x minus 2 and then x plus 4, this is us foiling. And let's just review the two ways that we had done this. One way was using the box. And with the box, remember that these are the outside terms now. So 2x minus 2 and x plus 4. And I can multiply those terms to get the insides and then add them all up to get it into standard form. So 2x squared minus 2x, 8x minus 8. And then I see my like terms right here. 8x minus 2x is 6x, and then minus 8. Right? Then the other way that we multiplied these terms is we knew we had to take 2x and multiply it by x plus 4. So we said 2x times x plus 4. And then we also knew that we needed to take negative 2 and multiply it to x plus 4. So negative 2 times that same x plus 4. So we set up our distribution to happen twice. 2x times x is 2x squared. 2x times 4 is 8x. Then negative 2 times x is negative 2x. And negative 2 times 4 is negative 8. And those are the same four terms we have on the inside of the box. And so we just need to combine the like terms, and we'll get the exact same equation we got previously. So 2x squared plus 6x minus 8. Okay, so again, how you multiply these terms out doesn't matter to me. Okay, you can do it whatever which way, using boxes, or the more formal way, which is kind of foiling, but not really foiling. You could even foil. Okay, and then the last thing we need to do is take this equation in factored form and now write it in vertex form. And again, there's going to be multiple ways that we can do that. Basically, what we need to find is the vertex. Okay, so when we're going from factored form to vertex form, how we want to find that vertex, there are a bunch of different ways. Okay, we could find the x-intercepts, average them out, plug it back in to find y, or we can convert it to standard form and do negative b over 2a. So let's say down here that number one, we want to identify the a value. Okay, and to identify the a value, it almost is going to be easier if we do multiply it and get it in the standard form first, because I can clearly see that it's this 2 here. Now, I could also pick that up, and I'm just going to write the equation again. 2x minus 2x plus 4. I know that my a value is going to be whatever happens when I multiply 2x times x, or the terms that have the x's in both of our factors. Okay, so you may not even need to multiply in the standard form to say, hey, my a value is going to be 2 times 1. Okay, so I'm just going to say identify the a value. If that means you multiply and get into standard form, fine. Or you can just multiply the coefficients in front of the x's. Then step 2 is going to be find vertex. And again, how you want to do that doesn't matter to me. Okay, when we graphed functions in factored form, we knew that the vertex was the middle or average of the 2 x-intercepts. So I could find x-intercepts, take the average, plug them back in to find y, or we could get it to standard form and do the negative b over 2a. Because I'm going to have us converting into all 3 forms anyways, why don't we just take the standard form and then find the vertex from there? Okay, so we're going to pretend that, not pretend, we already have converted this into its standard form, where I got it to be 2x squared plus 6x minus 8. From there, I can easily see that a equals 2. And then I'm going to find the vertex, negative b over 2a, by first doing negative b, which has me taking that b value of 6 and make it negative. And then 2 times 2 is 4, so negative 6/4. And as a calculator, or as a decimal, negative 1.5. Okay, and I'm not going to be picky on whether or not you'd write as a fraction or a decimal. Doesn't matter to me. And now to find y, I just need to take this x and plug it back in. I can plug it in anywhere. Okay, I can plug it into the factored form or the standard form. I don't know that one is better than the other. It's really just preference for how you're doing your work. So f of 1.5, since I'm working in standard form, I'm just going to use that standard form. So 1.5 squared plus 6 times 1.5 minus 8. And again, I'm just going to let the calculator do all that work for me. So 2, 1.5 squared plus 6, 1.5 minus 8. And we get y to be 5.5. So for the vertex, I know x equals negative 1.5, y equals 5.5, and now I just need to piece this all together into vertex form. So it would be f of x equals our a value of 2, x minus the x coordinate of the vertex. Remember, that's always going to be the opposite sign. So x plus 1.5, and that's squared, and then plus 5.5 at the end. So the last part is right in vertex form. Okay. Well, that is all the conversions that we need to do. On your homework, I'll just caution that you're going to get a lot of vertexes that are decimals. So you probably need a calculator as you work through the rest of this assignment. I have my answer key posted on Schoology, and the rest of the time is your time to get some work done. If you're stuck on any, I'm happy to come help you.